Okay, so this separable equation is, again, it's a derivative in terms of x and y. So this is a derivative equation, but it's an implicit function itself. But since it's in the form that it's times and divide on this side, I can separate those variables with the dx and the dy. Okay, some of them we can't, but these ones we can, and these are the ones we're focusing on. So I'm going to do y times dy on this side. And so basically I'm cross multiplying. I'm going to do x times dx on this side. And then I'm going to sum up both these sides. Okay. And I can, since this is compatible, y with dy, x with dx, I can easily integrate this. This becomes y squared over 2. And this becomes negative x squared over 2. And there's a plus c involved. Okay, so this is now my solution to my differential equation up here. And this one, if I rearrange it, I get x squared plus y squared, and that's equal to, and I times both sides by 2c. In fact, this general solution is a circle equation where 2c is my radius squared. So this differential equation actually is the derivative for a circle. And if I take a look at just the half circle, okay, we know the half circle formula. It looks like this: y equals square root of r squared plus minus x squared. If I differentiate this to find y prime, we can actually see that we're going to end up with this derivative. Okay, so y prime is equal to 1 over 2 square root r squared minus x squared times negative 2x. Okay, so that simplifies to negative x over square root r squared minus x squared. Okay, so this is my derivative. This is dy by dx. Okay, well, it doesn't quite look the same because there's a negative x, that matches. But this is y. But if we take a look at how we defined y, well, there it is. We defined y as r squared minus x squared square root. So in essence, this is equivalent to negative x over y. And that negative x over y equation calculates slope, just like this function would have calculated slope. So the general solution to this differential equation is actually a circle. Okay, and we can see that's true because when we differentiate half a circle, we do get that same derivative. Okay, so let's try some more here. These are, again, separable. If we can separate these out with times and divide, we can separate and integrate. So we want to put the y's on the dy side, and I want to put the x's and the dx's on the other side. Once I do that, I can integrate both sides. So basically separate, integrate. This becomes 2 root y, and this becomes x squared over 2 plus c. So there it is. There's the general solution to this differential equation. Okay, that's the general solution. If I want to solve it in terms of y, like I can isolate the y and make it a function of x. Okay, we can do that. Okay, some of these are really difficult algebraically, but this one, some of these are fairly straightforward. So we're going to end up with, well, let's do a couple steps here. We end up with root y equals x squared over 4 plus c over 2. And then I'm going to square both sides, so I get y is equal to x squared over 4 plus some constant. I'm just going to call that c2. And we're going to square both sides of that. And there it is. There's my function as a y equals function. So this derivative will give us this differential equation. If we differentiate this, it'll give us this differential equation here. So again, we can try this one here. It's the same idea. Okay, we kind of, if you're kind of following along, we can just keep going at this. If you're having a hard time kind of digesting this, go back a little bit, rewind this a little bit, and go back and kind of think about what we've just been doing. We've been separating the variables. In essence, this is a Riemann sum here, an equivalent Riemann sum here, and we've been summing up both sides. And this generates a y expression, this generates an x expression. Okay, so we'll move on to this one. This is going to be dy. I separate the y to this side, so I divide. Okay, the dx comes to this side. Okay, this square root x stays on the bottom. Integrate. This becomes log y. This becomes 2 root x plus c. Okay, so there's our derivative, our antiderivative. This is our general solution to the differential equation. And we can, if you want, we can again make this into a y equals equation by converting it to its exponential form. Okay, and again, this plus c, and I'm going to show you the steps here. Whenever we have this converted into the exponential form, really we can write this as e to the c times e to the 2 root x. Okay, so that plus c, okay, shows up as, so if we're adding exponents, we're multiplying exponents of the same base. So we can rewrite